All right, number 1, which number is irrational? A is negative 213 over 2. It is written as a fraction, which by definition makes it rational, so it cannot be irrational. 3.12 repeating, the fact that it is repeating makes it rational, so it cannot be irrational. The square root of 64 needs to be simplified. It comes out to 8, which is also a whole number and is very much rational. The last one, 9.31307 ... meaning that it goes on forever, tells you that this is irrational. Okay, your irrational numbers, non-terminating, non-repeating decimals. Number 2, which is the best approximation for the square root of 55? Now, the way I've taught you to do this is on a number line. The square root of 49 is 7. The square root of 64 is 8. Square root of 55 cannot be 7 and it cannot be 8 because those are perfect squares. If you can get close enough to come up with 7 point anything, I'll take it. Okay, I would have accepted B or C on that one. It would have been somewhere around here on your number line. Number 3 says to plot the square root of 51 on the following number line. Now, they've just given you whole numbers from 0 to 10. You needed to decide where the square root of 51 falls. Just like 55, 51 is between 49 and 64, but it is closer to 7. So I would put it here between 7 and 8, but closer to 7. And that would be my location for the square root of 51. It's just an approximation. Number 4, the square root of 144 is rational because it is a perfect square. Of 12. Okay, it is a whole number. It has no decimal. It can be written as a fraction. Several different correct answers here. Number 5 says that 10 pi is irrational because pi is one of the most well-known irrational numbers. Now, we approximate it at 3.14, but that is not a precise number. It is a decimal that goes on and on and on. And if you multiply a non-repeating, non-terminating decimal by 10, it's not going to fix the fact that it's irrational. It's just going to make it 10 times bigger, but still irrational. Because pi is irrational. Or you could have said because the number is a non-terminating, non-repeating decimal. Several different ways you could have described this. Any explanation that is correct gets you points. 6, approximate each number to the nearest tenth. We're going to find out which two perfect squares is between, and we're going to decide which is a better fit for it. The square root of 90 is between the square root of 81 and the square root of 100, which puts it between 9 and 10. Between 80 and 190 would be basically the middle. I would call this 9.5. I would approximate that at 9.5. Now, it might be like 9.51, but it's going to be very close to 9.5. Number 7, the square root of 71 falls between the perfect square of, 64 and 81. So we're between 8 and 9. It is closer to 64 than it is to 81, so I'm probably going to call this one 8.3. 8.2, 8.3, 8.4, I would have accepted any of those. the calculator comes up with 8.42. So 8.34, or I would have even accepted 8.2. Number 8, the square root of 72. It's just a little bit off from this one. Since I've already done it on the calculator, I'm going to call it 8.4. Again, you're going to be between the square root of 64 and the square root of 81. And you're not hardly to the middle, but you're very close. 9, 10, and 11, I realize that your calculators can do this for you, but I really want you to be able to do this by hand, so we're going to work through this the long way. I told you that if you want to turn a repeating decimal into a fraction, you have to make this into 2 equations. So start by setting the original equation equal to x. X is equal to 0.8 repeating. Now we're going to multiply by the place value, which is the tenths place. So 10 times x is 10x, and 10 times 0.8 repeating is 8.8 repeating. Once we have the 2 equations, we can subtract. So 10x minus x and 8.8 repeating minus 0.8 repeating. 9x is equal to 8, and then when we divide by 9, we get x is equal to 8 over 9. Number 10 is the same process, except this time we're dealing with the hundredths place. So we'll set the first one equal to x. Then we're going to multiply by 100. So 100 times x is 100x, and 100 times 0.89 repeating makes 89.89 repeating. Now we're going to subtract. 100 minus 1 gives me 99x, and 89.89 repeating minus the 0.89 repeating gives me 89. Then we're going to divide. And I did not find a number that would reduce this, so I left it at x is equal to 89 over 99. Number 11 was a little bit different because you could not just multiply this by the hundredths place. If you look at this one, it looks different because only the 6 is repeating. Now, we just need 2 equivalent equations. Instead of using x equals 0.86, let's multiply by 10 so that we can move the decimal. So 10x equals 8.6 repeating. So let's use this as the first equation, and my second equation, I'm going to multiply by 100. So I get 100x is equal to 86.6 repeating. What this is going to allow me to do is to eliminate the 0.6 repeating. So I have 100x minus 10x is equal to 86.6 repeating minus 8.6 repeating. Now the 0.6 repeating and the 0.6 repeating eliminate each other. 100 minus 10 is 90, and 86 minus 8 is 78. Now we're going to divide by 90, just like before. This will reduce. We can divide it by, I believe, 6 to get 13/15. Number 13, negative 11.3 is rational because, they're telling you it's rational. Now, it is rational because it is a terminating decimal. Terminating decimals are rational. On number 15, 0.083 repeating is rational because it is a repeating decimal. So if you're looking at rational numbers, they have to make a fraction, they have to be a terminating decimal or a repeating decimal, or they have to have no decimal at all. Now number 14 wants to know why the square root of 19 is irrational. The square root of 19 is irrational because Several different answers here. If you put it in your calculator, your numbers go on forever. Okay, it's random and it goes on forever. But without a calculator, the square root of 19, because it is not a perfect square. It's not a perfect square. It's in between 16 and 25. So you're going to come up with like 4 point some big bunch of decimal places that goes on forever. Okay, it's not a perfect square. Number 16 is also an irrational number. 2.1371938 ... Okay, those dots are telling you that this craziness goes on forever. That is the definition of irrational. Because it is not a terminating or repeating decimal. (17, 18, and 19, they're wanting us to convert these to fractions. 0.6 repeating, we're going to have x equals the 0.6 repeating. That is to the 10th place, so we're going to multiply by 10. 10x is equal to 6.6 repeating. Then once we have our two equations, we're going to subtract. So 10x minus 1x makes 9x, and 6.6 repeating minus 0.6 repeating makes 6. Then we'll divide by 9, which will give us x is equal to 6 over 9, which will reduce by 3, giving us 2/3. You also heard me say several times yesterday that 0.6 repeating is 2/3, just like 0.3 repeating is 1/3. Some of these fractions you should be able to get familiar with in your brain. On number 18, 1.1 repeating, this one is a little different just because it has a whole number at the beginning. It doesn't change the process. Set it equal to x. X is equal to 1.1 repeating. Go ahead and multiply by the place value. 10x is equal to 11.1 repeating. And then we're going to subtract. 10x minus 1x makes 9x. 11.1 repeating minus 1.1 repeating makes 10. We'll divide by 9 to get x is equal to 10 over 9, which is an improper fraction. If you was to make it a mixed number, you would get 1 and 1/9. Notice the whole number 1 here and the whole number 1 in the original problem. Number 19, 4.4, repeating. I'm going to set it equal to x. I'm going to write my second equation by multiplying by 10. 10x is equal to 44.4 repeating. Now I'm going to subtract. 10x minus 1x is 9x. 44.4 repeating minus 4.4 repeating makes 40. Divide by 9. And x is equal to 40 over 9. This is an improper fraction, so I'm going to simplify. 9 goes into 40 4 times and leaves a remainder of 4 over 9. Notice the whole number 4, and the original problem also had a whole number 4. 4 and 4/9. Last two. Number 23, which is an irrational number? A is a repeating decimal, that is rational. B is a perfect square, that is rational. C is not a perfect square, so we are suspicious. D is 11.2092 with no dots, which means it's done. That's the end. If it has an end, it is a terminating decimal, which makes it rational. That only leaves the square root of 20. If you are curious, the square root of 20 is very much an irrational number. Remember, when you got that radical, if it's not a perfect square, it's going to be an irrational number. Number 24. Which number is not equivalent to 13.02? That's 13 and 2 hundredths. This is 13 and 2 thousandths. 13 and 2 hundredths, 13 and 2 hundredths, 13 and 2 hundredths. So A was the correct answer here. And that is all.